Hey! Hello! We're gonna have some fun with if statements. And we're gonna get a little bit nutty with if statements. That's definitely what we're gonna do. And of course, hey, what is an if statement? The other one is that array list. We're gonna talk about arrays and what they are. So those are my main focuses that I have. And then of course the while loop. Okay. And okay, so we got if, while, and array list. Looks like some of the main hits on what we're going to be dealing with. So it starts with if statements and what an if statement is. And actually, if an if statement and a while loop, these are all what we call control structures. Why do we call them control structures? Because they control the flow of the mechanical operation of your program, what it actually does. And you can think of it spatially as going from function to function to function and completing, processing, adding onto the CPU those steps within that function that goes on the call stack. I just got ahead of myself a little bit. Okay, let's go back to if statements. All right. And control structures, while statements, and let's first talk about what we're controlling, and not just talk about it. Let's do it. Well, I've been doing it this whole time with you guys in the debugger. So let's see what we got. Let me get this zoomed in and prepped up. All right. So controlling flow. The only thing that a control structure cares about, and that's your control structures that control your flow for looping iteration and for decision making for selectively choosing regions of code to operate on versus other regions of code. And they only care about a true or a false. That's all they care about. A 0 or a 1. And so when I use the term 0, I'm talking about false within this, even though we got to use that true, false reserved word. I think it's that. Yeah, I think in Java that's the way it is. If true. And so and a control structure only really cares that what is in between its parentheses expresses as true. And if it does, then it modifies your flow. And that's what the if statement is designed to do. And so how does it modify your flow? That's what I'm showing you right now. Okay. Now, say we have just some lines here, and we have some other steps that we're going to do, such as print some information, whatever it is. But our flow for our program is going to start here, and I'm just doing a regular console mode program for this example, or for these examples. But I set a breakpoint there, and when I debug this, my flow is going to go and start right there. There's my runtime. And I'm going to flow on through, top down, like I should, with step over. It looks like I have some errors to fix. And oh no, I don't have any errors. I just got to actually do something in these guys so that it doesn't just ignore it. once we're doing something, then I can show you the flow. Oh. Okay, I think we can debug now and look at what happens with an if statement. Okay, so remember, an if statement just cares about something being true or false within these parentheses. That's all it cares about. And no matter what we put in between these parentheses, it's always going to be evaluated as a true or false because we're going to use what's called a regular expression in those parentheses. That's these guys. Whether something is equal to, less than, greater than, and these are all, excuse me when I said regular expression, a relational operator expression. So, a relational operator statement is probably a better term. These are what evaluates as true or false, because when we check one value to another value, we're looking and we're using this double equals operator to say, hey, are they equal? And that's a CPU process. Or we are looking at one value versus another value and saying, hey, is this one less than the other value? And so these always evaluate as true or false when you're working with them. And they get a little bit more complicated. And they follow the operator precedence and associativity rules when they are being evaluated within the if statement, within the parentheses of the if statement. So let's see, whatever. It doesn't matter if it's C or C++, the associativity rules that we look at. They're all the same. Okay, fine, Java. Okay, let's do that. Let's in case they got some kind of funky stuff, which, they already have. Okay, that's just fine. Yeah, there we go. That works. All right, that's for any language, I guess. And we look at the operator precedence and associativity for relational operators right there. So you can mix these guys all up in the same expression, but the thing is you must use a relational operator, some kind of operator within your expression that you have within this space right here on determining whether it's true or false. It's got to return a true or a false. Or it's got to be evaluated to a true or false. And we'll get more on that here. Let's look at flow. So, hey, it's true. Because I'm literally being stupid and I'm saying it's true. So that means if the if statement evaluates to true, control of the flow will go into this scope. And it will skip and not do these items or this scope. So let's look at it in the debugger. Okay, here we go. We're starting. Here's our flow. We just evaluated that line. Boom, we looked at this one. Oh, it's true. So we're going to run this line and we're going to output yes. And then we totally skip over this guy and we print out the information. Okay. So you see how the flow, the program only did these guys and skipped over that. And you can have multiple of these. You can have them inside of each other. You can have them stacked down above, multiples of if statements, if else's, else if, else ifs. There's all kinds of, there's a few different flavors of using an if statement and different ways of working with it. But it all comes down to this particular simple example. If I turn that to false, if something evaluates as false inside of here, then it is going to skip over this code and run this code instead. And so that's why we call it a control structure, because we're controlling the flow. So let's debug and look at this example. Okay, so this time it should print out no. Okay. All right, now a practical example. Okay, now you see here I'm using a relational operator, less than, and I'm saying, hey, if I is less than 4, so what happens before the if statement even looks at anything is this expression is actually evaluated first. And it looks at it, puts it on the processor, is I less than 4? And it sees that I is 3, so it's going to return a true. Now let's look at this, because we can actually take expressions and select the expression in the debugger so that we can add that as a variable watch. And those are nice and handy, especially when debugging. So I can look at what's going to actually happen here by selecting these guys, right click on it and say copy or add watch, new watch. And you see how the expression is I less than 4? And when I'm in scope, that I less than 4, when I'm in scope with my runtime, that I less than 4 is going to evaluate to a value. So it says here, I is not known. And that's because this line 18 has not run yet. We have not declared I yet. So I less than 4 just says, nah, I don't know what you are. So let's run this line. I is created. Okay, now the if statement, this line has not run yet, but since we selected that expression, we can look at what it returns. It returns a Boolean, which it should, and it returns a true, which is the only thing that a control structure cares about. So then it returns a true, and then it does exactly what I just showed you. So all it is modifying the flow of your behavior based on a specific trigger. That is done through relational operators and a true or false Boolean value. Now, how crazy can relational operators get? Frickin' nutty. Okay? Yeah, that's where we're headed next. Let's go. I always do a little nutty if statement run through on just right where you guys are at. It's kind of fun, but you can see the full complexity of an if statement and a control structure. And then we're going to go into loops. Okay, well, how nutty? Okay, yeah, okay. Oh, yeah, why don't we add a few things here? Let's add just one more variable. And then let's go a little crazy. And I have no idea what's going to happen here, but we're going to do this. We're going to say plus I divided by 2 minus 2 times 3 is less than 4. So you see what I'm doing here? I'm mixing regular expressions with relational operators, or regular operators with relational operators. What? Yeah, totally legal. Totally legal. Yeah, that's what it's for, because we can do very complex things with control structures. So I think that's crazy enough for now. Let's just evaluate what this is, and I'm going to show you how it's evaluated, and let's see if I'm totally wrong, because I've been wrong before. But I don't even know what this comes out as. Let's see. So what happens first? Well, we got to look at operator precedence and associativity. So we look up here to relational operators, and we see that it's at this level of precedence. So is there anything with a higher precedence? All the operators, and it looks like we have our regular multiplication, plus and minus there. So you see relational operators have a lower precedence than these operators. So these guys are going to happen first. Then these guys. Then your less than, greater than relational operators, these guys right here can happen. Okay, so there's not equals, equals, greater than or equals, greater than. They're all true or false relational operators that return true or false. That are mixed with regular operators. Well, you know, your normal processing operators. So let's see what it evaluates out to. We'll hit some. We'll hit some. We'll cheat afterwards. We're not going to cheat now. Let's run this later. But when I look at this, what operation is going to happen first? And that's going to be the 2 times 3. So that's going to turn into a 6. Oh, wait, I was wrong. No, it's this division. That's going to happen first. Okay. Well, I divided by 2 because it's left to right associativity. That's why this one happens first before that one. We learned that in grade school. All right, yeah, I is less than 2, or I divided by 2. What is I? I is 3. 3 divided by 2, that's going to be 1.5, but remember, this is integral, so it's going to truncate that and return a 1. And then we got I plus 1. I is well, nope, 2 times 3 happens next, doesn't it? Yep, 6. That becomes a 6. All right, and then 1 minus 6, this becomes a negative 5. Oh no, the plus happens first. I plus 1. That is a 4. And then 4 minus 6 is a negative 2. Oh, but we're not done yet, guys. Is negative 2 less than 4? Yes. True. Now the if statement looks at it. That's the big idea. Okay? All right. Now let's cheat. Come on, give me some good cheat. All right. That's the thing is, you know, you're taking a quiz. Why not have your compiler up? Because duh, it's going to tell you the answer. But okay, so I'm going to select this whole thing. And we know it should evaluate as true because we just did it. But what we can do is we can add a new watch with that whole expression and make sure that we know that that expression down here, if you see it now, evaluates as true. Okay? All right. Now we get into logical operators. Logical operators are going to be your and, or, so that you can combine relational operators together and have multiple relational operators. Logical not, logical and logical or. So that is so you can do this sort of thing. You can say, hey, is I less than 4 and is I greater than 0? Okay, now what does this do? Yep. Okay, what does the logical operator do? Well, if we look at the operator precedence and associativity, we see that a logical operator is right here, bitwise and, oh no, that's bitwise, excuse me, no. That's wrong, wrong, wrong. I'm going to tell you that these guys happen first. The logical operator is right there. But you notice here that we have another logical operator that we use quite a bit is the OR. So we use the and OR quite a bit. You won't see this use much at all. But these guys are what we use with relational operators to combine relational operators to get complex ranges of values or true false criteria. And you can combine them using the and or, and what that does is what we can use is a truth table to determine what actually ends up happening with those logical operators. So yeah, guys. Oh no, we're getting scribbly. Oh, yes, whiteboard, here we come. You know, last time I started the whiteboard, it took me forever to get this stupid thing running. Okay, here we go. All right. Yeah. Oh, I need touch screen so bad. Damn you. All right. So the logical operators, the relational operators that we have less than, we have the greater than, or, greater than, less than, equals to, the not equal, the double equals, the not, the not equals. Now the logical operators, you have the ampersand, the and, you use two ampersands, and then the or, you use two pipes. You do a shift, and it's the key right above the return key, and they're called pipes. They're also got other names, of course, but you put two of those in, and so this is what we call an and, because you can use it. You can use this term and to kind of think of how it works, and I'll get more in on that here. And this one is an or. And that's because when we add them, we combine relational operators with them. We can say, hey, is this true and that true? Or with the or, we can say, hey, is this true, this relational operator true, or this relational operator true? And if they are, only one has to be true, because we're saying, hey, or. We're saying this one or that one true for the whole thing to be true. And that's the expression use that we're going to be implementing through this truth table. You can think of it logically in that manner by using just plain English and or. Usually what do we use when we think of and? That means both. And when we think about or, it's one or the other. It's the same idea, but we're referring to the relational operators and their outcome. So that's why the relational operation happens first, then the and the or. Okay. So I'm going to be using zeros and ones here. Okay. A zero is literally at the lowest level. When you look at the false, keyword, it is essentially assigned 0. When you look at the true keyword, it's going to be assigned 1. So I'm using 0, 1. Just replace that term with true or false. So we're working with an and, if you have one operator that is one operation, relational operation, that returns a true, and you have another one that returns a true, the resulting answer is going to be a true. If you have one that is a true and the other is a false, since both of them have to be true for the resulting answer to be true, because we're saying, hey, this one and that one, then the resulting answer is going to be a false. If you have one relational operator that is false and the other is true, it's the same idea. The first one's false, so we're saying, hey, this first one and the second one has to be, true. Both of them combined true. So if one of them is false, the and breaks. And so that becomes a false. And then the last possibility is a false or a false, or false and a false. A false and a false. And that is a zero. So let's look at this. Let's look at this actually in the code. I is less than 4. Okay, so this is going to be I is less than 4. So I is less than 4, true. So that's going to return a 1 as true. Then we're doing an and. I is greater than 0. That's returning a true. So a 1 and a 1, a true and a true, is a true. So this comes out as a true. This comes out as a true. And when we say a true and a true, that results as the true. That's this guy right here. That's the answer. That's this guy right here. Let me move him around. That guy right there. That guy right there. This guy right here too. Those are the answers. So the first expression with the and, second expression. That's the answer, the full answer. And that's what the if statement looks at. So if we go back to the code, we've got 1 and 1 now. Well, we know 1 and 1 evaluates to a 1 or a true. So that's just evaluates as true, and we're off to the races. Okay? Now we can cheat. I love cheating. Well, I mean, come on. But only within, yeah. I love cheating with the compiler. Let me preface that. Okay. There we go. Now we can select this whole thing. We can select just that, add a watch to it, or we can select the whole thing and add a watch to it. And we got that down here as true. So it's going to say yes. Okay, now what's next? The or. Let's look at or. So remember, this wasn't saying, is this one true or that one true? Okay, then we got to get crazy again. One more time crazy on this, and then we're going to get into while loops and ArrayList. ArrayList and while loops. So while loops and ArrayList. Okay. All right, so with an or, only one has to be true. So we can do it something like this. This would be, hey, if I is less than 4, or I is equal to 10. So that means then that an or will be applied. So what we can do here is if we assign I to 20, I less than 4 is going to be a false. So that's going to be a 0. And then I equals 10 is going to be false. So a 0 or a 0 is a 0. So let's look at OR. Now in OR, if you take a true or a true, well, obviously a true or a true is going to be a true. A true or a false is going to be a true, because we're saying, hey, only one or the other has to be true. And then we're saying, hey, now went my stupid pen. No, you died. I think I pushed something weird. There we go. Okay. Yeah. Now the whole thing is just lost. Oh, come on. Okay. Pen malfunction aside, 1 or a 0, true. Same thing for a false or a true. It's a true. But when you got a false or a false, it's definitely a false. So you see, look at the symmetry that they have, and how they kind of complement each other. So here we're going to have a 0 or 0 is going to be determined as 0. But if we change this to a 10, now this evaluates as a 0, but this evaluates as a true, 0 or 1. So that's going to evaluate as a true, 0 or 1. This or the other has to be true for the whole thing to be true. So this evaluates as a 1. So those are logical expression truth table that you'll use. You'll be seeing this if you take any logic courses. You'll be seeing this stuff again. Logical operations and operands. It's done in straight up abstract English as well. Logic, pen and paper type stuff. Yeah. Yeah. But now I promise you we're going to get crazy with this. For that, let's just do something a little silly. Let's add another one. And let's just get nutty. And C times I. Yeah, let's do that. C times I minus 1, just to be stupid. And then let's just divide it by, I don't know. Frick. Let's divide it by 2. Yeah, let's just, okay. But you see, we can keep going with this all day long. We can add an or here and more crap. Yeah. But what do we actually really got? Well, if we separate this out with just looking at the logical operators, we know, yeah, let's do this. Yeah, we never finished this. I never finished this. J is less than. We'll do J is less than. And J plus I is greater than or equal to 10. Okay, so we got now three logical operations. Now how do we figure out what the, because this is legal, this runs, it's ugly, but Sometimes I see crap like this. Yeah. Well, I mean, not as bad, but this is pretty bad. But what it does is we just need to follow the operator precedence and associativity chart, follow the rules to determine how it's evaluated. In this way, you know, if we know how these things are evaluated, then we know we're gonna be that next step closer to creating our own, to synthesis of our own complex if statements. So what happens first? Well, relational operations happen before logical operands. So these guys happen first, but these guys happen first, and then these guys. So from left to right, my first thing is C times I believe. So that's negative 2 times 10 right off the bat. Isn't that negative 2 times 10? Is that negative 200? Oh my god, that's horrible. Oh, we're changing I. Changing I. I'm sorry, but negative 2. Let's just get something a little bit more round. So let's say that this is the first expression that happens that we got to do. C times I. Okay, well, C is negative 2. I is 2. So we're going to go with negative 4 here. All right, and what happens next? The division, 1/2. Okay. But 1 divided by 2, that's integral. We're using 1 literal divided by 2 literal. So that's going to truncate. That's going to be 0.5, and it's going to truncate to 0. Which minus 0 is going to be gone. Now what happens? Well, J plus 1. Everything else is broken down. J plus 1. 3. Okay. Then what happens next? I is less than 4. Is I less than 4? I is 2. That returns a true. I equals 10. That is a false. J is less than negative 4. That is a false. 3 is greater than or equal to 10. That is a false. Okay, then what happens? Well, now we look at operator precedence and associativity, and we see the ands happen first. So, and are they left to right or are they right to left? What's their associativity? Shit. Jeez. Left to right. Okay, so we do left to right. So we're going to do this one first. If it was right to left, 0 and 0 is a 0. And then we have another ampersand left. 0 and 0 is a 0. Then we have a 1 or a 0. That's a 1. True! Yay! Let's find out if I lied to you. I might have lied to you. Let's find out where the crazy happens and get it back. Okay. Let's go with it. We're cheating. We're now cheating, yes. Oh, the heck with it. I'm not even going to do a breakpoint. Yeah, okay, cool. Or not even do a watch. Okay. Alrighty. That's the dig on if statements and relational logical operators. Alright. Now we are going to get into while loops. Alright, a while loop is a repetitive control structure where it makes sure it has your allows your flow to continue and repeat. And we do a lot of things with loops. That's a main tenet of computer science is repetition. That's what computers do better than humans. So looping is an extremely important part of control structures, right up there with if statements. So let's look at it, and it works just like an if statement. All it cares about is a true or false. That's all it cares about. And this is how you would, build something that you would continue until a user entered a key where you break it out of the while loop or something like that. But what we've done is we've just now created a runaway loop, and you can see it just does. It says here, loop should not be infinite. I don't even think it'll run. It doesn't. It's probably. Oh, okay, it'll run. But it just says, okay, yeah, okay, it'll continue. It'll stop itself because it knows the interpreter excuse me, the the Java virtual machine knows eventually after a while that it's gonna stop itself. It'll look ahead and it'll see. Look right now. Look, it's just looping over and over, outputting. Yeah, you're right there or something. I don't know, whatever. Okay, so I've caused a problem there, but that's what a loop does. Is it just continues over and over and over again. So let's look at the behavior. Okay, step over, step over, step over. Okay, now we're on the loop. Step over. Okay, I just did an output. I just output a yes. And then, wow, maybe it did not like me very much. Oh, it just decided to go to hell. Oh, wow, okay, the JVM does not like me today. Okay, well, evidently I can't demonstrate an infinite loop. But it's the same idea of an if statement, but we're going to put some limitations on it, on how much it can iterate, and we usually do that with a counter, some kind of value that we start and we accumulate, and that's what we call is an accumulator. So this is going to be a loop counter. And we typically start at 0, guys. 0 is actually number 1, so get used to thinking that way. 0 is 1 in computer science. 1 is 2. When we get to ArrayList, you'll understand that a little bit more. Actually, that's part of ArrayList talk, starting at 0. All right. Well, yeah, I'm pretty sure they use. All right. Let's see. While true. Let's put some limitations on this. We're going to say while count is less than 3. Okay, now problem is here is count is always going to be less than 3. Unless I do something in the loop that increments count. And so what we can do is we can say count is equal to the previous value of count with 1 added to it. And now count's going to iterate each time through the loop. It's going to iterate by 1. So let's look at the behavior now. Okay, we got there. Count is less than 3, so we're true. Okay, we're repeating. Okay, now is count less than 3? Because count was 0. We got count now is, oh, we got it down here. Count. Here's 2. Okay, it's now 2. Okay, is it less than 3? Yes. Okay. Now I want to give you a clue on how you should be doing counters. You should never start a counter at 1 and do something like this. Less than or equal to 3. Okay, if you want this loop to run 3 times, and you want to start it at 1 and go to less than or equal to 3, this is not really good code. It's not based on 0. So the way you should always do your counts is if you want a loop to run 3 times, always start your accumulator at 0. And you go to the less than the amount of times you want to run. And that will handle for all your fence post issues within algorithms. Like we call them off by 1 errors. And if you start accumulators at 1 and, or counters, not accumulators, counters for loops at 1 and go to less than or equal, you're going to have some weird +2, -2 fence post errors. And I mean, literally, when I see that kind of code, I delete it. People just laugh at it, actually. So start at 0, guys. Go to less than the number you need to. That is a tenet. If you're not setting up your loops that way, your code does not look good at all. It's like amateur. So 0 less than the number you're going to for your counts. Now that'll run 3 times, and so instead of printing yes, let's just output this. Let's do count, and let's do a print line. I think they got a print line, so it'll put a new line at the end. Print line right there. Yeah. And so it'll print the count and then each line it goes through. Okay, and now when we run it, we see that it outputs 1, 2, 3. If I set a breakpoint here and we go through it, we got count. Count was at 0, now count is at 1, now count is at 2. Now count is at 3. It's ran 3 times. Look at the output. Okay, so it's run 3 times now, and count is now at 3. So you see it's 3, it's looking at count, which is at 3. If we look at the debugger, not the debugger, but the watches and the variables, let's see, where's count? Right there. It's 3. It's no longer less than. So it's gonna fail and skip out and go down. Control is gonna go down to here now, and whatever we do down here, we can, whatever code we have out here, whatever, let's inject a new line and then say done. Because we don't have to do print line, we can just do print and inject the new line in if we want to. Okay, let's run it. Okay. There's our done. Okay. Oh, we injected the line. Oh, we just did a double line. That's stupid. We don't need that. That's why it's got that silly thing. But anyways, that's a while loop and that's repetition. They work very similar to an if statement, and they'll continue to repeat until the condition becomes false. Then it bounces out and return of your flow goes outside down. So remember, your flow is top down, always top down. And then when you do looping, then it repeats over and over, top down. And then the control of the flow goes out to here, line 25, and you continue on with the rest of your program, whatever that code is. All right, now we're going to use this here. We might use it to walk the array list. We'll see. Let's get into the PowerPoint on ArrayList. We got through quite a bit here. There's some of the stuff I'm going into detail on what matters. So there's a lot of stuff that I simply don't have enough time in the world to cover with the videos. So ArrayList class. So that's where we're headed here. Let's continue on with that. ArrayList class. Here's some set no values. Okay. Nested loops. Okay. Where's your other? there we go. There we go. All right, that's what I wanted to get to finally. The ArrayList class. Okay, so um, the reason for using loops and starting at 0 is for arrays. And in Java, we've got some really nice fancy arrays that we can use with a lot of that makes it easy to use them. And we can use indexing and subscript operators with them and functions with the array list. And when we instantiate an array list, we can describe what data type is being put into the array. And this is an example. We can have, and actually, you know what? We need to get into Scribbly's a little bit, just so you can know what an array is. An array list is a really, it's a fancy low-level array that's implemented with automatic memory growth. So as the array list gets bigger, the memory will grow with it. With this type of one, usually the way it's implemented, Python, I'm pretty sure in this one too. I think I looked it up. The array list doubles every time it needs more size. If you start it with a specific size, and you can keep adding to it. But the problem with it is it has to double and copy things over. So let's look at what arrays are and talk about some of the limitations of this type of implementation. All right. Now, an array list is a fancy array. An array is a contiguous block of memory. A contiguous block of memory that represents locations for what's in the array. And we call those locations references. Other term pointers. But Java, actually everything's a pointer. You just don't know it. Which is beautiful. I love that. Because I don't have to care about pointers. I love that. But it's a contiguous block of memory in RAM. And let's say that you have a byte 0, the memory in this case is going to be dynamically allocated on the heap. This is actually heap allocated memory. It's not on the stack. That's why you have to use everything comes from the heap in Java, so whatever. But it's going to ask for memory, and then you can start filling in the array list with references. And this array list is what it does is it stores references in subscripts of the array that then point to the actual memory of what's being stored at that location. So this could be a series of integers. The actual integer primitive, I think they might be more direct, but it could be an object, a string, anything essentially. And I'm wondering if they can do mixed, but yeah, pretty sure that you can have mixed data types on. No, you can't. No, not this one. Not this example. So you will have just one data type on it because they're used templates and they haven't got it that advanced. But you can have a sequence of the same data type, and that is accessed through subscripts or functions that are part of the array list itself. And that location in RAM is a contiguous, it's an actual physical place. And let's say that this is at address 5000 And then this is address, whatever, 5,000. Well, it'll be 4 bytes for each reference. 4 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 times 4, 44. So it'd be 5,044. 5044 right there. My scribbles. Oh my God. Okay. Uh, but each item, each object goes onto that subscript contiguously in that location, and it points to the data of where that is at. And it could be a string, it could be a boat object, all of them are boats, and we access what it points to through the reference, which is the array list. And we can use the subscript, or what we call the index. So this would be location 0, 1. And that's why I recommend, or no, excuse me, I am so enthusiastic about not starting loops at 1, because it's 0. And when you think about it in terms of actually taking a value and representing it in mathematics, 0 is implied. So I mean, are we in the 21st century, the 22nd century? Where are we as we're heading to the first one? Or where does the first one start? And in memory, we have location 0. That is where things start. So everything is 0 based. So all the memory that goes in your array list begins with that 0 index, and then each one is appended on as you add them. Now, how they're appended, whether they go here or what happens as they're appended, that's all based on the tools that are available within that particular library, which is the ArrayList of Java. And so what they have available are these functions to work with, such as add. Here's how we instantiate it, how we ask for that memory. And then we can work with the array list and operate on the array list and find out specific things about the information within the array list using the functions that are available for that memory. So it's wonderfully object oriented, and the fact that the array list has everything you need to manage it. It's just how you use it is where the difficulty comes in. And there's always multiple ways of doing something. But these are the functions that you can use. And we should be able to use, let's see, how are they actually outputting? They're outputting it by getting the index, by using the index and the get function. Okay. Looking good here. We are going to go play with ArrayList. So let's create a string ArrayList, I guess. That would be easy. Let's not go crazy. A string ArrayList that'll hold some words. And actually, let's go actually use our example. Let's use our example right here. Right there. Okay. Oh, it might be a little tricky getting this code in there. Oh yeah, of course, yeah. It did not like me. Yeah. Yep. I figured as much. You're gonna have to like me a little bit more there, guy. This is where we get Control C. There we go. And back to our code. There we go. There. All right. Let me get rid of white space just in case there's some crazy stuff in here. Oh, shit. Okay, there we go. All right. Come on. Silly freaking thing. All right. All right, let's see if it builds. We're good. We're creating an array list. Oh, what are we forgetting? I think we might be forgetting something. I betcha. Oh, nice. Let's look at the example code. I think I forgot something important. Getting some weird things like, hey, what is it? Import. No. Import. Yeah, I think I brought it up here. What was it? Import. Yeah, this guy right here. Here it is. Okay. In fact, we're gonna grab this code and play with it. All right. Do we have an array list that works? Oh. Okay. Let's see. Amateur hour. It's got to be underneath. Okay. We are good. All right. Now we can set up a breakpoint and look at what happens when we create the array list. Okay, we look down here. We're going to go to variables and we're going to look at what's in scope. Array list should be showing up here somewheres. We can add it to the watch though. Oh yeah, the array list is names. Yeah, let's go back to that. Should be here. There. Yeah. Okay. Yeah. All right. And it has nothing. It says size 0. Array list of string. Now, let's add 3 names to it with a loop using a counter. And we're going to have some fun with this. This is going to be fun. Yeah, this will be fun. We're going to use the loop to generate names that start with the capital letter and just generate a string, an alphabet, A, B, C, D, E, F, G, and add those to the list. It's just going to be a single character string. We could add a little bit more. I might just say whatever, but let's do that. That'll be fun. So that means then we need to go to less than 26 because we're going to add every character in the alphabet to it using the count. And what we can do is let's get our memory, print our memory. Let's just print every character that I want to add. And what I can do is right here for count, I can create a string char count, or no, CHR. Let's just do CHR for character string, for characters. It's a string of chars. It's a char string. One char string. Yeah, one char string. Okay, let's see. Now we're going to add it to the, we're going to add CHR to the array list. But what we want to do with CHR is I want to modify it so that it has the A character to begin with, and then B, and then C. And I can use the count variable, because I can say count and take the ASCII code value of the capital letter A, which is 65. And remember, ASCII code chart, ASCII code chart, ASCII code chart. It's going to be this guy right here, and we'll just use the coordinate, the 65. We'll add the value 65 to it. I think that's where A starts. 61? No. Yeah. 65, capital A. We'll do capitals. And then what we need is we need to take the char, the integral value, convert it to char or a string. So let's do Java convert int to string. And so we're going to use this code to do the conversion from the actual numerical value that we're going to assign it, 65, to show up as the capital letter A. And so we're just using the loop to walk through A, B, C, D, E, F, G, and the ASCII code. So let's look at that code that actually does the conversion. So what we want is we want this. CHR is equal to something with 65 in it. And I believe we're going to do a char. We can do a char cast or whatever. Now let's actually, yeah, we're going to have to actually use char first. So let's just do this word, string word, and let's get rid of this stuff because it's just casting, but we got to go with a char first before we can get to the string. Char ch, and then we're going to set ch equal to word will be the word that we generate, and ch will be equal to the char value of 65, something like that. But what we're going to do is we're going to do it here. Ch is equal to, take the count and convert it to its char equivalent. And that should give us the capital letter A, but we got to take count plus 65, because count starts at 0. And then that has to happen first. Before we convert it to a char, I don't know. This is looking a little funky. Convert to the char first. Oh no, add 65 first. Then convert to the char. We probably don't need that outside. Probably don't need that outside setup, but I'll be explicit. Let's look at this. Okay. And let's see. build successful. All right. I want to set the breakpoint down here. Okay, here we go. Count is less than 26. Step over. Count is equal to count plus 1. Okay, now we want CH. And let's cheat. I'm cheating. Oh, yeah. Because I want to know. I want to know. Does it work? Yeah, letter B. Oh my God, we got a fence post. What? No. That's supposed to be capital letter A. No. How did we get a fence post? I can start at 0. Oh, fence posts are normal. And I'm only off by 1. If I would have started a count at 1, I could be off by 2. Who knows? Well, why am I off by 1? Oh! Duh! Look at that. I need to convert first because I'm added 65. So that needs to be here. Okay. Okay. Off by 1. Alright. Looks like that was an easy fix. Good. Alright. So that actually works. It's generating a capital. It's generating a letter. Now, can we assign it to Word? Now they should have the plus operator overridden to add, let's see. To add a character to a string. So that's what we're going to do. But to do that, what we can do is we can say word is equal to a string plus ch, but that's kind of silly. Why don't we do this? Why don't we use word? Can we just? No, I didn't think it would do that. They do have it so you can append it with that, I believe. Let's see. Yeah, I think that should work, but this is kind of scabby. Well, let's at least do this. Let's at least initialize that one. But that's okay. We're just essentially take a string, add it to that, where there's another way to do this that's better. Let's actually, yeah, the pen should be overloaded for this. They should have some kind of append, yep. Look at all that. Oh, I'm being so silly. Java needs to use a string builder. Yeah, that's right. Okay, let's get into it. String builder. Let me go find that real quick. Okay, we got a good example of string builder here that I'm going to implement so that we can append that string and just do some silly stuff. Let's see. Let's get that. Getting too complicated. So this guy should do it. Yeah. Again. Let's get scabby. I don't know if I want to do that. I don't want to do that. Let's just see if this works. I'm being stupid, but Okay, let's see. Did it work? Come on, hack the system, hack the system. Yeah, it worked. Frick yeah, okay. None of that other crap. Let's just be scabby because it's easier. It's simpler that way. No pen string relic crap. All right. That will do the addition, but what we can do is we can continue to get silly with this because couldn't I just say the heck with that? Just grab this thing. Throw it in there. Okay. And let's add another one. Whoop whoop. Oh no, that's messing it up. I almost messed it up. Okay, now we're going nutty. All right. Alrighty. Let's have fun with that. Let's see what you do, Mr. Wordy. Let's see what you do. Let's see. Okay, let's look at Word. Okay, it's not step over. Is it ABC? Or could it not handle it? Yeah, BCD. BCD. There we go. Oh, we're doing the stupid count thing wrong again. Okay, so this has got to be... I didn't do that yet. I was being silly. Okay, here we go. There. Now this is what I intended all along. Finally, we got there. Took a little time. Okay. Here we go. We're using an accumulator to walk through a loop. We're using the loop to process a result. And we are adding the result to the array list. The next thing to do would be to use a loop to print the array list. Each thing at a time. So now I'm going to call this generated names for the array list. It could be just generated, and it's a simple start. You could generate anything you want like this from the ASCII character code. You can even implement random within it and go really nutty, but we're not going to do that. What we're going to do is we're going to take Word, and when we're done with everything, let's get rid of that. Let's just print Word for now. Get a look at what that is. Then we're going to add it to the array list. Okay. Oh, duh! I'm writing the wrong code again. Print. Okay. All right. Okay. Step over. Word. Word is ABC. So we got our output. There we go. All right. I'm going to get rid of this and hit continue so it continues on. Why? Okay. There we go. There it is. All right. So maybe we should do print line. Okay, but that's only when we're generating it. So there it is right there. Well, it went a little bit off of the the 26 characters. Look at it went into the next batch of ASCII. But right now, this is just printing what's generated, and that's what was put on the list. Because what's put on the list is what's important. It's in our RAM, and whatever's on that list is what we work with when we're sending that data either to disk or whatever we're doing. Send it to a database. Yeah. streaming it, all kinds of different things that we do with memory and RAM. Let's walk this. Let's parse this. And we're going to use a while loop at a count that's inside of the list. So while, and we're going to reset count down here to 0 again. Well, count is less than, but this time we're going to use look at all this good fun stuff. We're going to insert it here. And then we're going to have a while loop that walks through it and prints it. All right, so let's use the member access operator to add the word to the generated names. Okay, let's come back to this here in a little bit. And let's just see and determine that it's getting on the list. Got ahead of myself there a little bit. Okay, step over, generated names. Should show up on variables on the autos. Generated names right there. Okay, first one's there. Location index 0. Okay, and then it continues on, and you see our locations are growing as we step through and keep adding these on as we repeat. I'm stepping over, and you see how the flow is moving through, generating them and increasing the variables that I'm looking at. This is how you code, guys. You don't code any other way but in the debugger. Use it, guys. Just use it. Okay. All right. So we're getting the names on the list. That is working. Now, and for that we need a count that starts at 0 and goes to less than the size of the generated names list. And we're going to use the size function to get the size. And so now we have a loop that will run for however many items were added. And we happen to know it's 26, but we don't want to hard code that into the loop that's working with an array list. It could be any size. We want to we don't want to hard code. This we hard coded. That's hard coding. But that's fine. We're generating. We're creating the data. So in this case, we got an array list. We want to use the size variable so that we don't hard code stuff. And that's going to return 26. And so count is going to always be looking for less than 26. And I'm creating a problem right now because I want to get my counter working correctly. So I'm going to set count equal to 0 and immediately go in here and set count is equal to count plus 1. Now I'm ready to walk the list. And we can use, let's see, what are some of the different ways of doing it? Oh my, you're probably laughing at me. Yeah, this video is getting too long. Yep, we're done. I'm done because when I start doing this kind of stuff, that means, yeah, okay, it's break time. Yeah, okay, system.out. Okay, we're going to use the get function. The get function with the count of generated of generated names. We're going to apply the get function and assign the count. The count is going through the index starting at index 0 of the array generated names. And so I just need to actually print this. Print, and let's do a print line. And we'll set a breakpoint here so that we can actually look at this happening. And we'll go through it. Okay, good. We got generated names.size. That's going to return 26. It's right here, generated name size 26. And so we're going to get the first one at index 0. So if we look at count, index 0, count is 0, and we look at generated names and we break that down, we look at location 0, and we got ABC. Okay, and now this is index based, ABC. Okay, good. We got it. And we will continue. And it looks like we're going to end up printing everything in the list. So let's get rid of this breakpoint and let's look at some output. And we're going to call it good. We've taken ArrayList for a test drive. We've talked about while loops and looping. We've talked about if statements and while statements. Those are all the most basic and big main ideas of the chapter. And so, yeah, I'll leave you guys to it. Have fun with that JavaFX stuff, man. That stuff's great.